Okay, before we go on to talk about testing for ions and gases, etc. Okay, we've just done precipitation, so it's probably a good idea just to start thinking about what is soluble and what isn't. So you have to learn this, and this will be very useful in the next section when we're talking about testing for ions and the particular products of those reactions tend to be insoluble, tend to be a precipitate of some variety, white or coloured, which gives you an idea of what you've got in solution. So solubility rules, these are straightforward. You might as well sit down and learn them now. So what's soluble? All sodium, potassium and ammonium salts are soluble without exception. All nitrates are soluble. So if you're looking for a soluble salt, always choose a nitrate. Most chlorides, bromides and iodides are soluble, but the two key exceptions are lead and silver. Okay, lead and silver. The colours of the precipitates, I think we've already mentioned at some point, but lead precipitates of the chlorides, bromides and iodides tend to be yellow. A fairly pale yellow with chlorides, a slightly more intense yellow with bromides, and an intense yellow precipitate with iodides. Silver, we'll talk about the colours soon, tend to be white chloride, silver chloride's white, bromide, silver bromide is a cream or buff colour, and silver iodides are yellow precipitates. Sulfates are soluble, with the exceptions of barium, calcium and lead, and they are all white precipitates. Insoluble, carbonates. So whenever you're looking for something that you think will be insoluble, a carbonate will almost always be insoluble, apart from with sodium carbonate, potassium carbonate and ammonium carbonate. Okay. Oxides tend to be insoluble. They're often, we've seen them when we're making salts. We can use a metal oxide and we add an excess of the metal oxide because it's insoluble, and then we can filter. Group 1 and group 2 oxides typically tend to react with water. So when they do, they produce the hydroxide, but it looks like they dissolve. They actually react and the solid disappears. Hydroxides, insoluble hydroxides. This is one of the ways that we're going to identify many metal ions by the colour of the hydroxide precipitate, but the exceptions here are group 1 and calcium hydroxide is slightly soluble. So sodium hydroxide, potassium hydroxide, lithium hydroxide are all soluble. Calcium hydroxide is slightly soluble. Barium hydroxide is actually soluble too, but you shouldn't be asked that at this level. Testing for ions. So you need to know how to test for anions and cations. Let's remind ourselves. Anions go to the anode, so anions are negatively charged. Cations go to the cathode, so cations are positively charged. So this will be a little bit like CSI. You'll be given a solution and you'll have to identify the anions and cations present. The first anions we're going to test for are halide ions. What are the symbols for halide ions? Chloride, bromide and iodide. So the steps to follow. We add 3 centimeter cubed of the suspected halide to a test tube. Okay, so there's a solution of the suspected halide. If we're given a salt as a solid, we'll have to dissolve it in distilled water And then we'll take 3 centimeter cubed of that dissolved salt. We add an equal volume of nitric acid, and then we add 1 centimeter cubed of silver nitrate solution. And we look at the color of the precipitate, and you'll see in the following table what the colors are. Now, why do we add nitric acid? Well, we add nitric acid because it destroys any carbonates that might be present. As you know, acids and carbonates react to produce carbon dioxide and a salt. So in this case, a carbonate potentially that could give a false positive can be destroyed by the nitric acid. Why nitric acid? Well, it simplifies the situation because nitric acid contains the nitrate ion, just like the silver nitrate that you're about to add. So we don't complicate things by adding extra anions. Let's have a look at the colors here. If the color of my precipitate is white, then that indicates the presence of chloride ions in the solution. We can test this. There's a further test from this precipitate, which we'll talk about in a minute, okay, using ammonia solution. If I get a cream or buff precipitate, then bromide ions were present. And if I get a yellow precipitate, iodide ions were present. Try and write the ionic equations for these reactions. So we're producing silver chloride, silver bromide, and silver iodide. There's the ionic equation for the production of silver chloride, silver bromide, and silver iodide. Solid because they're precipitates. Okay. We can doubly test this by adding ammonia solution. So silver chloride precipitate, if we add dilute ammonia solution, it will redissolve, and that confirms that we had chloride ions present. If it doesn't redissolve in a little bit of dilute ammonia solution, then we might have had bromide or iodide. So we add excess dilute ammonia solution or concentrated ammonia solution. If it dissolves, then we had silver bromide. If it definitely doesn't redissolve in dilute ammonia solution or concentrated ammonia solution, then we know that we had silver iodide. So it's a further confirmatory test. Okay, there's lots of videos online for these reactions, so you can see them. There's a video there that I've pasted a link to. Another test for iodide ions is using lead nitrate solution. And lead nitrate solution contains lead ions, and when they meet with iodide ions, as we mentioned before, they give a bright yellow precipitate. You can see that in this video here. You can click on that. The ionic equation for that reaction is that lead ions, 2 iodide ions produce lead iodide, which is a beautiful bright yellow color. You get a real sense for why they're called precipitates, because when this is formed, the lead is so dense that the precipitate rains down to the bottom of the test tube. Okay, sulfate ions. So, similar kinds of steps. We add 3 centimeter cubed of the suspected sulfate solution to a test tube. We add dilute hydrochloric acid this time. We'll discuss that in a second. And then we add 1 centimeter cubed of barium chloride. A white precipitate indicates the presence of sulfate ions in the solution. Okay. What's the ionic equation? Well, there's the ionic equation. Barium ions in solution, when they find sulfate ions, produce barium sulfate, white precipitate. Okay, why do we use hydrochloric acid? It's to kill any carbonates, to avoid false positives. Barium chloride has got obviously the same anion as hydrochloric acid, so we don't confuse things. We could use nitric acid and barium nitrate because barium is also soluble, isn't it? So basically, any solution of soluble barium ions will show us if we've got as sulfate. There's a video there for you to watch so you can see what's happening. Carbonate ions. Well, we've said carbonates tend to be quite insoluble. Okay, so if we've got a carbonate, there's a good chance it's going to be a solid rather than a solution. So we take a small amount of the suspect solid or solution and place it in a test tube, add 3 cm³ of dilute hydrochloric acid, and test any gas given off by bubbling it through lime water. And lime water is calcium hydroxide solution. If the lime water turns milky, a carbonate was present, as CO2 was evolved, because we know that acids plus carbonates give carbon dioxide. Okay. So if I've got magnesium carbonate and I add some acid, this is the equation that I would write, isn't it? And there's my carbon dioxide given off. If I split up the ionic compounds here to find the ionic equation, it looks like that. I can't split this up because it's insoluble. So essentially the hydrogen ions are attacking and producing carbon dioxide. There's a video there for you to watch. Nitrate ions. Similar kind of idea, slightly more complex reaction going on here. 3 cm³ of the solution, had some sodium hydroxide and some aluminium powder or pieces of aluminium foil. We heat it gently and then we test any gas evolved using damp red litmus paper in the neck of the test tube. If it turns blue, that means ammonia has been given off, and that means that nitrate ions were in the original solution. No equations are required because it's quite complex chemistry. It's actually redox that's taking place, but it's too complicated for IGCSE. There's a video there for you to watch. Sulfite ions, also known as sulfate 4 ions, are a little bit more tricky. So with similar kind of idea, we add some hydrochloric acid to the solution and then we warm it gently. And any gas produced, we bubble it through potassium manganate 7 solution, or we place some filter paper soaked in potassium manganate 7 in the neck of the test tube. The gas will be pungent. The gas that's coming off is actually sulfur dioxide. So if the solution or the potassium manganate 7 on the filter paper goes from purple and pink to colorless, then the sulfite was present because sulfur dioxide causes it to go colorless. What does the equation look like? Well, if you have hydrogen ions from the acid and they react with the sulfite ions, they produce sulfur dioxide and water. And you can watch a video there. Right, time to slow down, read the pages indicated, and try the questions. That's a lot of information to take in.